So the topic for today is absolute value inequalities, and we're going to be solving these inequalities. And what we need to talk about first is some basic functions and what an absolute value inequality means. And so I'm going to deviate from the notes for just a minute and just do some simple examples to kind of show you how this system of solving these was set up. And so we're going to come back to this gray box which has basic functions in it. And we're going to go now and I'm going to do some examples. So first of all, let me give you a simple example. I have an inequality that says the absolute value of x is less than 5. Okay? So what we're going to do in order to solve this, since this is so simple of an example, is we're going to draw a number line and we're going to look at that number line and we're going to think of what numbers on the number line will work for in this inequality. So here's my number line. I'm going to put a 0 on it. And I'm actually going to put a 5 on it since we have absolute value of x is less than or equal to 5. And here's the thing. When we have absolute value, remember that makes whatever is inside positive. So first of all, let's think of what positive numbers will make this inequality true. So in other words, I'm going to put this up on my number line and I'm going to block all the negative numbers because I only want to think of what positive numbers will make this true. So the positive numbers that will work in here is any value that's less than 5, right? That makes sense. So I'm going to draw just that part of the solution. So an open circle at 5 and anything less than that, okay? And I'm just considering for the moment positive numbers, okay? And I don't want to think, oh, 1, 2, 3, and 4, because I got to remember there's all those fractions and decimals in between the integers. So there's fractions and decimals that are very, very close to 5, but less than 5. So I'm going to do an open circle at the 5. I'm not going to think, oh, only up to 4. So here's what I have for my positive numbers that will work. Now, let's cover up the positive numbers. And what negative numbers would work here? So wouldn't it be the same numbers but negative? So for example, -1, -2, -3, -4, anything that's to the right of -5. So if I put my -5 out here, -5 wouldn't work, but anything in between 0 and -5 would work. Now, when I take away the ruler, look what I have. This is my solution. Do you remember this from our last unit? We had graphs that looked like this. And this was a conjunction, right? It's an and combined inequality. So this is a conjunction. And so if we write this, this is the way the solution looks. -5 is less than x is less than 5. So our solution is between -5 and 5. All right, so now we're using material from our last unit. Let's do another example, and this time we're going to do a greater than example. So I have absolute value of x is greater than 3. And we're going to do the same thing with the number line. We're going to look at the number line and we're going to see what works. So I'm going to put my 0 here, and since we're working with 3, I'm going to put my 3 in here. And again, I'm going to first just consider the positive numbers that will work. The positive numbers that will work in here are any positive number that is greater than 3. Does that make sense? So out of the positive numbers, these are the numbers that are going to work. All right, if we look at the negative numbers, what negative numbers will work in here?
Anything less than -3.
Exactly, anything less than -3. Anything that is more negative than -3 is going to work. So I'm going to draw that. And I'm going to take away my ruler, and you're going to see what our combined graph looks like. And this is a disjunction. This is an or, combined inequality. And remember, when we write this, we have to use the word or. So we're going to say x is less than -3, or x is greater than 3. And that's our solution. And this sets up for us something very important. It sets up how these are all going to work, no matter what's inside the absolute value. Whenever you have absolute value is less than a positive number, your solution will always be a conjunction. When you have absolute value greater than a positive number, your solution will always be a disjunction. The numbers we'll have to calculate, but when we have less than a positive, it'll be a conjunction. When it's greater than a positive number, it'll be a disjunction every single time. All right, so that's setting up for us how this is going to work. So let me give you another example. How about this? We have the absolute value of x is less than -2. And let's just think about this for a minute. What would be the solution to this? Now, would any positive numbers work in here? Would any positive numbers work? No positive numbers work. Let me ask you this. Will any negative numbers work in here? No. Because the absolute value is always positive. Positive is never going to be less than -2. And that means our solution is no solution. And this sets up for us another rule. Anytime you have absolute value less than a negative number, your solution is no solution. All right? The next example is absolute value is greater than -4. So let me ask you, what positive numbers will work in this inequality? What positive numbers will work here?
All real numbers.
All of them. And then you go to negative numbers. What negative numbers will work here? And the answer again is all of them, because absolute value is positive, and any positive number is greater than -4. So this would be all real numbers. And anytime you have an inequality that has absolute value greater than a negative number, you're going to have a solution of all real numbers. And if we go to this chart that I handed out to you, that's exactly what we have here. Whenever we have absolute value less than a positive, your solution is a conjunction. When we have absolute value greater than a positive, you're going to have a disjunction. When you have absolute value less than a negative, you have no solution. And when you have absolute value greater than a negative, you will have a solution of all real numbers. All right? So these two are going to be the easy ones. These two we're going to have to calculate. So now let's go to some basic examples on page 5 of our notes. And what we just talked about is the basic rules that are in this gray box. So we're going to do some examples, and they're already worked out for you. We have absolute value less than a positive number. So this is going to be a conjunction. And here's how you're going to set it up. You're going to put the 2x minus 5 in the middle. You're going to put that positive 3 over here on the right. You're going to put the negative of it, negative 3, on the left, and you're going to have two less thans. So you're going to make a conjunction. This is your solution. It's just that you need to add 5 and divide by 2. So I'm going to add 5 to all three parts. Then I'm going to divide by 2 in all three parts. And my solution is 1 is less than x is less than 4, which means x is between 1 and 4. All right? I have a second example using the same numbers. Absolute value of 2x minus 5 is greater than 3. Since it's greater than a positive, it is a disjunction. So let me set that disjunction up. One part of the disjunction, and remember you have to have the word or, but one part is this same inequality without the absolute value bars. That's here. 2x minus 5 is greater than 3. The other part is 2x minus 5, switch the sign to less than, switch the sign to negative 3. So these two things, the sign and the sign, have to change. That's what's going to change. Now I'm going to solve both of these by adding 5 to both sides and dividing by 2 on both sides. And I'm going to get x is less than 1 or x is greater than 4, and that is a disjunction. In C, I have absolute value of 2x minus 5 is less than negative 1. Remember, any absolute value less than a negative is no solution, no work to be done. Here I have absolute value of 2x minus 5 is greater than negative 4. Anytime you have greater than a negative, your solution is all real numbers. So let's turn the page and go through some examples. All right, our first couple of examples are pretty easy. I have absolute value greater than a positive number. Remember, check on your chart. Greater than a positive is a disjunction. That's going to mean with the word or. One part of this will be the same inequality without the absolute value bars. So n is greater than 1. On the other side, we still have the n. Flip the sign, make the 1 negative. That's your disjunction. If we go to B, I have absolute value less than or equal to 5. Here we have absolute value of B is less than or equal to positive 5. Since we have less than or equal to a positive number, this is a conjunction. So here's what we're going to put in the middle, that B. We're going to have less than or equal to's. We're going to have negative 5 on the left, positive 5 on the right. All right, C. In example C, don't pay any attention to what's inside the absolute value because it does not matter right now. All we know is that we have less than a negative number. So what solution is this going to have when we have absolute value less than a negative number? This is no solution. Here, I have absolute value is greater than or equal to a negative number. So what type of solution is this going to have? This is all real numbers. No work needs to be done. Now, here's something different. What's different is I have something outside of the absolute value bars. What I need to do is, before I decide if I have a conjunction, disjunction, no solution, or all real numbers, I have to have absolute value by itself. So the first thing I'm going to do is subtract 1 on both sides. And I get absolute value of 2x is less than 8. Now I have absolute value is less than a positive number, which is what type of solution? Conjunction. So here's what we're going to do. Put 2x in the middle, less than and less than, and it's between negative 8 and positive 8. Now I'm going to solve my conjunction by dividing all three parts by 2. And so I have negative 4 is less than x is less than 4. And this is my solution. All right, my next one, I have absolute value is greater than a positive number. So I'm going to have what type of solution? Disjunction. So I'm going to put in my word or. Over here, I'm going to write this same inequality minus the absolute value bars. So 3x minus 1 is greater than 8. On this side, I'm still going to have 3x minus 1. Flip the sign to less than, change the sign to negative 8. Now I've got to solve both of these. So add 1 to both sides, and I have 3x is less than negative 7. Divide both sides by 3, and I have x is less than negative 7/3. Or, here add 1 to both sides, and I have 3x is greater than 9. Divide both sides by 3, and I have x is greater than 3. And that is my disjunction. So let's go to G at the bottom of the page. Again, I don't have absolute value by itself. Before I can decide what kind of solution I'm going to have to get absolute value by itself. So I can't look over here and go, oh, negative number, this is either going to be all real numbers or no solution, because my absolute value is not by itself. So first, add 5 to both sides. Now I have absolute value of 5 minus x is less than or equal to 3. What kind of solution will this have? Conjunction. So the 5 minus x goes in the middle. We have less than or equal to and less than or equal to. Over here we put a negative 3. Here we put a positive 3. And the next thing that we're going to do is solve this. So subtract 5 on all three parts. And I have negative 8 is less than or equal to negative x is less than or equal to negative 2. I need to get that x by itself, divide everything by negative 1. And I have 8. Flip my sign because I divided by a negative, so greater than or equal to x is greater than or equal to 2. And now I just need to flip this around by reading from right to left. This is 2 is less than or equal to x is less than or equal to 8. H is a little more difficult. Here's why. It has absolute value on the left and 0 is on the right. 0 is tricky. When it comes to having 0 on one side of an absolute value inequality, you really have to think about what it means each time. Now, on the chart, Notice, I've got all the possibilities laid out for you and how all the solutions are worked. So you're able to memorize these. But you've really got to think about what you're supposed to do. So here's what I've got. Absolute value is greater than or equal to 0. And I have to consider the whole concept of greater than and the concept of equal to separately. Because it's going to be different than if it were just greater than. All right? So here's what I've got to do. When is absolute value greater than or equal to 0? This is actually going to be all real numbers. And here's why. Absolute value, the lowest thing it can be is 0, because the absolute value of 0 is 0. Otherwise, it's always positive. So the possible answers that you can get for any absolute value is 0 or greater. All right? So it could be equal to 0, and it could be greater than 0. And that defines what absolute value is. But here's the tricky thing. If this were just greater than 0, then here's what would happen. This cannot be equal to 0. And so what happens is we're going to go to this chart and we'll look for absolute value greater than 0. And what that means is all real numbers except one value. And that's the value that makes it 0, because it can't be equal to 0. So you would figure out what makes it 0 by setting it equal to 0 and solving. And it's all real numbers except that one value. All right? So 0 is a lot more difficult to deal with than positive and negative numbers. All right, let's go to another example, and it also has 0. Before we can decide what type of solution we have, we need to get absolute value by itself. In this example, that means multiply both sides by 4. And so I have the absolute value of 3x minus 11 is less than or equal to 0. And this is another 0 problem. Here's the issue. I'm going to look at the possibility of less than. Can absolute value be less than 0? In other words, can it be negative? No. It cannot be negative. So it can't ever be less than 0. Can it be equal to 0?
Yeah.
Yes. So there's only one solution to this inequality, and that's whatever makes this equal to 0. And if you look at our chart right here, absolute value less than or equal to 0 is going to have one solution. That solution is wherever what's in the absolute values is equal to 0. So let's go back to this, and all we have to do is set 3x minus 11 equal to 0 and solve. Add 11 to both sides, and I have 3x equals 11. Divide both sides by 3, and I get x equals 11 thirds. That is my only solution. Now, if we go back to this chart, if I have absolute value less than 0, can absolute value ever be less than 0? No, because it can't be negative. So this is no solution. But if we have less than or equal to, we're going to have one solution, and that one solution is that one value where it's equal to 0. So 0 is a lot more complicated. All right, next example. We have absolute value equal or greater than or equal to a positive number. What type of solution will this be?
Conjunction.
Pardon?
Conjunction.
This will actually be a disjunction. Greater than or equal to a positive number is a disjunction. So this is going to be or, And my one side is going to be the same inequality without the absolute value bars. So 2 plus 1/2 x is greater than or equal to 3/2. The other side, I still have 2 plus 1/2 x. Switch this to less than or equal to. Switch this to negative 3/2. On both sides, the way to solve this, get rid of the fractions. Multiply everything by 2. 2, 2, 2. Do the same thing over here. So on this side, I'm going to have 4. The 2's cancel, leave me with x is less than or equal to. These 2 cancels, and this gives me negative 3. Subtract 4 from both sides, and I have x is less than or equal to negative 7. Or, over here, I'm going to start with 4. These 2's cancel and give me plus x is greater than or equal to. The 2's cancel and give me a 3. Subtract 4 from both sides, and I have x is greater than or equal to negative 1. All right, let's go to k. All right, absolute value less than a positive. This is a conjunction. The way you're going to set this up, put the 3 minus k in the middle. Put less than and less than. On the left is negative 2. On the right is positive 2. Now solve. So subtract 3 from all 3 parts. And we have negative 5 is less than negative k is less than negative 1. We need that k to be positive, so divide everything by negative 1. And I have 5. Because we are divided by negative 1, we need to flip our signs. Is greater than k is greater than 1. Now read this from right to left and flip it around. 1 is less than k is less than 5. Let's go to L. Before we can decide what to do, we need to get absolute value by itself. The first thing we're going to do, subtract 6 on both sides.
I have a question.
This is the same equation as this. Notice how I've just replaced this absolute value with an n.
Yeah.
The way that you would solve this is the same way you would do this.
Okay.
And just the same way you know you wouldn't add the 6 and the 5 here, you cannot add the 6 and the 5 here. You would subtract 6 and then divide by 5. So I've got 5 times the absolute value of 2x minus 3 is greater than or equal to negative 1. My next step, divide by 5 on both sides. And I have absolute value of 2x minus 3 is greater than or equal to negative 1/5. Now I have absolute value greater than or equal to a negative number. What is this solution? All real numbers. Greater than or equal to a negative number is all real numbers. All right, the very last inequality we have here, we need to get the absolute value by itself first. So divide both sides by negative 5. What do I need to remember to do when I do this? Flip the sign. So I have absolute value of x minus 6 is less than or equal to 0. And here I have a 0 problem again. And remember, when we think about this, it can't be less than 0. So there are no solutions for the less than 0 part. But it can be equal to 0 if x minus 6 equals 0. So that's how we're going to find our one solution. Set x minus 6 equal to 0. Add 6 to both sides, and our one solution to this inequality is x equals 6.